Okay, so here's our second video. We're still working with elimination. Again, we're trying to eliminate one of the variables so that we only have one and then we can use substitution. First step, are they lined up? X over x, y over y equals constants. Okay, we're good. Is there a common coefficient? I look at my x terms. Yeah, those both have a 1, right? That's what that is there. So I have a 1 and a 1. And I look at my y and I have a 4 and a 1, and 4 and 1 is not the same. So I'm going to use my x. Remember in the last video, we were able to add those together. So if I add 1 plus 1, I'm going to have 2x, right? Well, that's not eliminating anything. So what we need to do is instead of adding, we're going to go ahead and use, but we're not going to add, we're going to subtract. Now watch what happens here. I need to subtract the entire equation. This might get you. So one of the things I like to do is when I put that subtraction there, I go back and I change all of my signs. So remember, I would have to distribute that negative. So this means that my 1x is negative. This negative y becomes positive y, and this 3 becomes negative. That negative has to go to everybody. I have to make sure everything in that equation gets that. So I'm going to tell myself, okay, I took that negative all the way through. Now 1x minus 1x, well, now it cancels. 4 plus 1, I have 5y, equals 13 minus 3, that is 10. Now I'm still solving for y, so I'm going to divide both sides by 5. That'll leave me with y equals 2. Well, now I know half of it. I just got to go find the other half. So it doesn't matter, again, which equation I use. I'm just going to use the top one. I have x plus 4 times y, so x plus 4 times 2 equals 13. That would be x plus 8. We're just simplifying. And now we can move that 8 across the equal sign by undoing. X comes down, the 8's cancel, as mathematicians told it to do, and 13 minus 8 is 5. So I believe that my solution is 5, 2. Now remember, we can check that. Go back to both equations, 5 and 2. I would have 5 for x plus 4 times 2, and 4 times 2 is 8, and 5 plus 8 is 13. If it helps you, go ahead and write these. Put a check step out to the side, write them out, make sure they are correct. And then we have 5 and 2 here. Now you can put it back in the original equation, or you can use the one after you have distributed the negative, but be careful because if you made a mistake with distributing, it might be off. So I'd actually probably want to go back to the original equation. Remember, that was x minus y equals 3. Well, if I put in 5 minus 2 equals 3, is that true? Yeah, 3 does equal 3, so checks. All right, I know I'm correct. Let's go ahead and look at another one. Here I have 3x minus 10y equals 14, 3x minus 9y equals 15. Check steps. Equations lined up. X over x, y over y, equals over equals, constant over constant. Good to go. Now we can combine. Is there a common coefficient? Well, that's important. I have a 3 and a 3. Yeah, those are common. And I have a negative 10 and a negative 9. Not common. So I want to use the ones that are common. I'm going to use these 3's. But if I add them together, it's not going to work very well, right? If I add them together, I'm going to have 6. And I want them to eliminate. I want them to subtract out. So instead of adding, I'm going to subtract the entire bottom equation. Again, this is where you have to be careful because you have to make sure that that negative, that subtraction goes to everybody. So this 3 is subtraction. This negative 9, well, becomes addition because a negative times a negative equals a positive. And this 15 is now negative. So let's look at this. 3x minus 3x, we canceled that on purpose. Negative 10y, positive 9y. That would be negative y or negative 1y equals 14 and negative 15 equals negative 1. Still solving for y, and I got that negative there, so I'm going to divide both sides by negative 1. And I now know that y equals 1. So I want to give you kind of a little bit of a tip. If this part here where I put this through and I changed all my signs is confusing, it is absolutely a good strategy to rewrite the equations. So I might have, instead of distributing this way, let's say I would rewrite it. So I'd rewrite the top equation because I didn't change it. And I'd just rewrite it as is. And then I would rewrite the second equation with the distribution. So I say, okay, so I distributed the negative, and now it's negative 3x. Now it's plus 9y. And now it equals negative 15. So that's another way of doing it, is to rewrite the problem as you distributed and then work the problem. So you're going to have to think, which way works best for me? You have to be careful because the positives and negatives will trip you up. Let's go back. I'm not done. Remember, we have to have an x and a y, and I've only got the y, so we got to go find the x. Doesn't matter which equation, I'm just using the top one. 3x minus 10 times 1. Remember that y is 1, or multiplying, equals 14. So 3x minus 10 equals 14. Okay, moving that 10, so we're going to add 10 to both sides. And 3x is going to equal, well, 14 plus 10 is 24. Two-step equation. Now we're just going to divide by 3, and x equals 8. Now I have a solution. I know what x is, and I know what y is. So my solution, x, y, make sure you get those in the right order, 8, 1. Use your check step. This is where I ask you. Pause that video, go back, plug it in. Did it work? If it did not work, you need to go back and rework the problem. Look for misadding, or maybe you didn't distribute correctly. Those are the top ones. Make sure that when you have combined something that you know exactly where it goes. Be careful, but that check step will save you from having incorrect answers. All right, here we go again. Are my equations lined up? X over x, y over y, equals over equals, constant over constant. Got that part. Common coefficient. Now that I know I can combine them. I got a 3 and a 3, and a negative 4 and a negative 4. Huh, they're both common. Okay. Now let's think, can I add these or subtract these to make something disappear? I want to eliminate. The 3 and the 3, if I add them, that's 6, right? That's not going to work. If I take 3 minus 3, yeah, that's 0. If I take negative 4 and add them, that'd be negative 8. But if I subtracted them, that'd be negative 4 minus a negative, so plus a positive, and negative 4 plus 4. That would work. So either way, it looks like I need to subtract this bottom equation from the top. So let's do that. Now again, we need to distribute, and I'm going to show you if I would have just wrote it out on the side. So if I would have said 3x minus 4, I'm going to keep the top, and I'm going to distribute the bottom. So when I do that, that's negative 3x, positive 4y equals positive 13. And then I'm going to work this equation. So 3x and negative 3x. I combine them. What does that equal? Yeah, those cancel, right? That was really what we were trying to do at the beginning. Now I have negative 4y plus 4y. You can be like, well, negative 4y and positive 4y, those cancel, right? But here's the thing. We can't leave nothingness. This is an equation. It has to have something to hold the equal sign. If I write the equal sign, there has to be something over here. So what number would represent the fact that these both canceled? I'd have to write 0. Don't leave it hanging out over there. You've got to give it a number. Negative 10 and 13, well, that makes 3. Then you're like, oh my goodness, 0 does not equal 3. What did I do wrong? We didn't do anything wrong here. Remember, we have problems that will look just like this. They will end up with a number equals or a number, and it may be true or false. This is a false statement. If it's a false statement, that tells me that this has no solution. So if I graphed these on a plane together, no solution, these would be parallel lines. These would be parallel lines. So there's not a great way of plugging this in and checking it because I don't have any solution to plug in. So another way to do it would be to graph it quickly if you wanted to do that, or you could set it up and put them in y equals mx plus b. So that is our topics here about subtracting out. Again, the subtraction key is that you have to get that negative distributed all the way through that second equation. You cannot stop. It has to go from one side to the other. No matter what's in it, it has to distribute through. So one way is to look at your problem and distribute it and change your signs within your problem that you already have, or like we did on the last one here, rewrite them and work slowly. Those are your two options.